Hi everybody, this is Tor Storley and I am back with another video. In this video, I like to look at DuckDB and the spatial extension provided by DuckDB. I also want to look into something called Jinja, and I also want to analyze geospatial data using VS Code and Python. So without further ado, let's get started. Okay, so let's take a look at this. So first, some housekeeping. What I want to do first is I want to mention that you can find the DuckDB documentation here under duckdb.org at docs. Make sure you check that out. If you're looking for the spatial extension, go under extensions and go down to, you see, spatial, and there's some information about that. Another one we'll be using is this HTTPFS, which is a way of loading or reading files directly over the internet. So make sure you read that too if you're interested. I like writing SQL. I don't like writing necessarily queries in Python. So I'm used to SQL language. So in order to do that, I downloaded this Magic DuckDB. And what you can do is you can pip install Magic DuckDB like this in your virtual environment. And you can also go to the Magic DuckDB website here on GitHub. And I'll put some links in here so you can see it. I'll actually put them into the notebook when I push it out to my GitHub repository. And you can go to look at different notebooks and see how they do their Magic DuckDB references. You can check it out here. Another thing you can do is go to Jinja, which is a part of what we're going to be looking at. There's a Jinja website too that looks something like this. Now I want to use it just to create SQL queries, so I'll show you how that works in a little bit here. I want to open up my notebook in VS Code. So I have a Python notebook here in Visual Studio Code. And as you can see, I'm pointing to my Tor environment here, virtual environment. I have my references set to this folder here, which is the DuckDB Spatial folder. And I have one file here plus my workbook right there. So that's what I'm going to be working on. So the first thing we want to do then is to import some libraries. So as you can see, I'm importing DuckDB, Magic DuckDB, Pandas, requests for HTML scraping. And I have pandas, and there's also a reference to the LXML library as well. And of course, this is how you load the Magic Duck extension in this Python notebook. All right, so let's run that and make sure we get that to work. The next thing you need to do is you need to make sure you have this spatial and the HTTPFS extensions installed and loaded. Now I happen to have installed both of these, so this is how you do it. But I'm only going to load them because I have them already installed. All right, success, that's good. Now what I want to do is I want to query a file over the internet, a GeoJSON file. Out here, I have a repository that I have been using before. I think it was my SQL Server Geospatial video series I used this one in. So let's open that up and see what that looks like. Okay, so the first thing we want to do is we want to go to my GitHub repository, as you can see here. And I have a data folder, as you can see. And in there is some files. It has an extension of JSON, but it's really GeoJSON. And I created those in SQL Server a long time ago, I think. So anyways, I want to set a reference to this GitHub repository. And then I want to go and get the files from here. So you can see it's under this folder structure here. And I'm going to get this file here. And the next one is the Illinois County Census as well. So those are the two I want to use for this demonstration. So here you can see I'm going to go over the internet and query this. And in order to do so, I'm going to use this HTTPFS. Here is how you can do it. You query directly here from this GeoJSON file, and I just want to get 5 records back. But keep in mind, it's a JSON file, so it's not going to look like records. So I'm running it, and it came back after about 1.8 seconds. So here you can see what it looks like, the data. The next thing I want to do is I want to create a local GeoJSON file from this GeoJSON file on my GitHub repository. So how can I do that? Well, I'm setting up a timer here, and I'm using this DQL. Now, in case you wonder, I'm not going to spend time on this. Go to my previous video where I talked about Magic DuckDB. I will explain it more about this DQL and this double percentage DQL, etc. It should be in that video, so spend some time there if you need to know more about it. So I use the copy keyword. I'm selecting everything from this file, and I'm going to save it to this file that is going to go to my current folder working directory, and which is this one right here. And you can also do a quick check on where that is by saying, let's say, add a code cell. I can do the PWD with a percentage in front of it. So as you can see, this is the actual directory, which is the one I'm in, so that's fine. I want to go and get that file, that GeoJSON file from my GitHub repository, and I save it locally here. And it's running, and it probably, ran in 2.3 seconds. So as you can see, here is that file, is the Illinois counties right here. You can see that. Okay, so that's good. It gives you a 1 here because it's a JSON file, so it's the one big text string. Now, one thing I mentioned in my introduction is that there's something called Jinja. Now, why would you worry about Jinja? Well, when you use Magic DuckDB and you have to write dynamic queries, sometimes it gets kind of tedious because you have to write a bunch of text strings, and it has to have maybe 1 or 2 or 3 single quotes in the text string, or double quote with single quotes, and it just gets kind of messy. And sometimes it's really hard to get it right. Now, this Jinja offers you a couple of things. It offers you a way of inserting into the text other text that may be variables. Also, you can create like loops and everything within the Jinja library, or the Jinja2 in this case for Python. Now, I wrote some references here. You can see, you can take a closer look at that. So let me show you what Jinja does, and particularly for my purpose. I create a variable sort column. I create a variable sort direction. I set it to some text, and then I have a single percentage DQL statement. So this is going to run on the same row, the same line, I should say. And then you have this dash Jinja2 before the query comes. So I'm selecting everything from this data frame, and I'm going to order it by this column and this column right here. So let's see what that one does. First, I have to create a data frame here. So let's use this data here to create a data frame. So all it is some dates and some distances. So this is assuming like you have written down what kind of runs you did throughout the week for like workouts. So you run 5 kilometers or you run 3 kilometers, and let's run that and create some data. So I'm running that, and it's done. So what I can do now is, in using Jinja, I can refer to that data frame, and then I can say, I want to sort. So if you look at what I'm doing, I'm going to have a sort column that is dates, and I want to sort it descending. So that means I want the most recent date first. So let me run that. And now you can see it sorted it. So it basically uses this squiggly and variable name squiggly as a placeholder in the text, and it fills in whatever you have here. So that's what the query becomes. So if you look now, for example, if I want to sort it by dates, but I want to in the way it was, so I can just change this to ascending again. And when I run this now, it will sort it the other way. So you can see now it has the oldest date first, and it's sorted down. So that's one very simple example of how to use it. I can check the types. So let me check the types of this data frame. And it tells me dates are object, distance are object. Now, in pandas, object typically means it's text. So I don't want the dates to be text. So let me go and see if I can fix that. So I'm going to just convert the dates column into a date time. So let me run that. So let's convert it into a date time format like this. Let's check the types again. So now you can see it's converted to a date time for the dates. Okay, very good. Now let's go scroll down a little bit. And this query here is a more complex query than the recent one we just saw. This one is going to generate a pivot query. Notice how it has all this information about what it does, so you can read up on this. But as you can see, there is a for loop in here. There is a case statement in here with a dynamic replacement, the run type. And there is a dynamic alias for a column name. And there's some grouping. So what I'm doing basically is I'm setting up a list of run types, 5K and 3K. Those are the two categories. Then I'm setting up a reference to a variable here. And I'm having triple quotes here. And then I have my query inside. So I'm saying select dates. And then I have this squiggly percentage kind of format, which Jinja is using, where you have a for loop. So for run type in run types. So it's going to pick each one of the 5K, the 3K. And it's going to kind of loop it. And then what it's going to do is going to sum up the case where the distances are the run type. So remember, the distances we had before was 5K and 3K, right? That was up here, right? 5K and 3K. So I want to basically sum up all these and figure out how much there is of each one. So that's what I'm doing here. So I use a case statement to flag it as a 1. Otherwise, it's a 0. So when you have a 1 and you find another one, it'll be 2 and so forth. If it's a 0, 0 plus 0 will be 0 and so forth. And then I simply have this equal total underscore, and then the distance is going to be total underscore 5K, total underscore 3K. And if it loop and it checks and see if it's the last record, and if it's not, it's going to continue. Otherwise, it's going to end. So then it ends the for loop here. So it's a little tricky language to figure out. But let's test it. And then what I'm saying is group by 1. As you can see up here, that means I'm going to group by the first column in the query, which is the dates column, because that's what I'm using here. That would be the first one. And then I'm going to sort it in ascending order. So let's see what this query will look like. I'm going to print it out. So let me run. And here you can see this is what it looks like. So I can just copy this query now and scroll down. And what I want to do is I want to place this one right here. And then I'm going to run it using the DQL, Magic, DuckDB, and this Jinja2. And what I'm doing here is I'm saying -t because I want the output to be in form of a data frame. So this is going to generate a data frame of the results. So let's run that and see what that pivot query looks like. So as you can see now, it has the dates here, and then it has total. It didn't add the distance here. Okay, so I made one little change to this query I had, and I changed the distance to run type, because basically that's what we're looping on, the run type, which is this or this. So let me run that one more time, and let's copy that again. And then put it down into the query below here. And let's try to run it now and see what happens. So it ran, and now you can see it prefixed with tot underscore, and then the run type is 5K and 3K. And as you can see here, this one here now is 1, 1, 1. So the next thing then is, what if I want to see the total within this week that I ran for 3Ks and 5Ks? How can I do that? Well, it's pretty easy. All I have to do is change the date to week. So instead of showing individual days, I use this date part function, and I'm looking for the week, and I call it week. And by doing so, I can group it and sum it up that way. So let's run the same query now, but with the date part of week. So I'm running, and I got an error. Okay, so I had the data frame in the wrong place. So let's try to run it again and see now. And here it is, as you can see, when the week was 11, and total of 5K is 1, and we had total of 3Ks 3 times that week. We ran that distance. So you might ask yourself, why do we do this? It's kind of kludgy and so forth. Yeah, I agree to a certain extent. The nice thing about this is, for example, let's say you have a regular query, right? So let's scroll down a little bit here. So I add a little bit to this notebook here in hindsight, just to kind of hone in a little bit. Now this is what it would look like if you ran a regular query over it. Now, if it was a numeric, the 5K, the 3K, if those were numerics, you can write a CTE and make them numeric by making them 1 or 0, and then do like a pivot query if you want to. But this is kind of what it looks like with the 5Ks and 3Ks. So here's a regular query, as you can see, where I simply use the sum over case statements. So if it's 5K, you make it a 1, otherwise 0. So when you total all the 5Ks up, you're getting one sum number. So when you run something like this, that's fine. It works, you get the number. The problem is that what happens if you want to add more distances, like 7K, 10K, 15K? After you got to keep adding and adding and adding, and it becomes a little tedious. So an alternative way of doing that, since you're working with data frames here, would be to actually use Jinja. As you can see here, I added more values here. Let's say you changed your data frame and you had more dates and you had more distances, as you can see down here. I'm adding the 7K, the 10K, 7K, 5K. And as you can see here, I added more dates as well. So it's more than a week now. So one way we can do that is we can still create this data frame based on this, but we can also, and obviously we need to convert the dates, but what we can do also is we can fix it up so we can get all the unique values for the distances. So we'll extract 5, 3, 7, 10, as you can see, K. And what we can do therefore is we can run this to create the data frame. And as you can see, this is what it will look. And then we can actually run this statement here. And notice you get an array of 5, 3, 5, 7. Okay, there's an error here because there's a little k. That shouldn't be there. And now we got 5K, 3K, 7K, and 10K. So that looks better. So what we can do then is, because we changed the run types, we can extract each one of those out in this statement here. So we build this query dynamically, basically, with more run types and more dates, etc. now. So it's a nice, clean way of keeping the query the same, but keep adding to it in that data frame, as you can see. So when I run it now, you can see it still produces all of the columns, and they're in a pivoted format. You can also do the same, obviously, for the 2 weeks now, because the dates are more than 1 week. So what happens then is it simply pivoted just the way it should, and it sums it up. But now you have week 1, which is 11, and week 2, that is week 12. So it's just a nice little feature you can actually use to make the queries a little more dynamic and more interesting maybe, and simplified, kind of. I don't know, the wording and the templating is not that simple, but it's an alternative. I just wanted to show you that it's possible to do it this way. So that's how you can use Jinja in here. So that's something like this. Now let's use Jinja and let's go back to our spatial data and try it again. So what I'm going to do now is I'm going to copy that GeoJSON file from GitHub, but I'm going to use Jinja syntax. As you see here, what I'm doing is I create a base URL here, and I'm creating my California file like this, and then I'm setting it to JSON format. And if I had a CSV file, I would set it to this format. So here I'm saying DQL, Jinja2, copy, select everything from this base URL plus this file. As you can see, I put those two together, right, like this. And I have it inside single quotes. And I'm going to copy it to this file name. So that would be this CA file right here. And the format is going to be this JSON format. And that's what I have in this variable here. So that's how you can copy it using Jinja. It's a little cleaner when you write it out, particularly if you have a lot of data. So now I got an exception again. Okay, so I had an error, but the reason was because it's case sensitive. So this base URL up here needs to match this one here. So let's try it one more time and see what happens. Let me run it. And that looks better. So it's copying it over, and there was one over here. So now you can see here's the CA counties also loaded into as a JSON file. I want to load in a more efficient way when I do it. Here I just did one, but that was only to show you. Now let's set up a script that can actually do all files and like 3 or 4 files in a row. So the first thing I want to do from this folder, I want to delete the stuff that I just got in. So anything that ends with JSON, anything that ends with CSV, I'm going to be deleting, removing from this folder. So I'm importing the OS, I'm setting the current directory to OS get current working directory, creating a file list where I use a list comprehension to look for all the files in the current directory that ends with JSON or CSV, and then I'll loop through the file list, which is this list, and then I remove anything that it finds in there, and then it just prints out how many of file you deleted. So let me run that. So here you can see you deleted these 3 files. So now you see they're gone from over here. So what I want to do now is I want to actually create a function that can actually get this stuff, and also want to set up the base URL, and I want to run this through. And again, I need to fix this so it matches this, because that's the problem I had. All right, so there's 3 parts to this one. One, I'm setting up a timer. Then I'm creating this function, which is going to get the format. So what I do is I take the file name I'm passing in, and the files comes from here. So the file name is this one. I split it on the period sign so I can get the extension. And then I have 4 files, 3 JSON files, so GeoJSON files, and 1 CSV file. So I'm going to pass it to this function in a loop, and then I'm going to split it so I can get the extension. And then I'm going to say JSON format is JSON, CSV format is CSV with a pipe delimiter, because there's only 1 CSV file in here, but it uses a pipe delimiter, and it has a header. Then I'm going to look for the extension. If it's JSON, I'm going to return the JSON format. Otherwise, I'm going to return the CSV format. And this just does what we just did. It sets up the base URL and all that stuff. And here's the formats. So let's now run this code. It's going to loop for each file in those files. It's going to get the format using that function. And then it's going to use this Jinja and copy the one from the base URL file to the file using the file format it gets from the function up here. So let's run that and see what that looks like. So notice over here now you're going to get some more files. So it's running, getting 1 file, 2 files, 3 files, and 4 files. So it's done. So as you can see, it took very little time, but 5-6 seconds for loading all these files in here. They're not large files, but it's still over the internet. So the next thing we're going to do now is we're going to visualize those spatial data in Kepler Map Viewer extension. So what is the Kepler Map Viewer extension? Well, if you go to VS Code sidebar here and you go to these extension, there's an extension you can download, or install I should say, called Geodata Viewer. So just search for Geodata Viewer, and when you do, it's going to look like this. Now I already installed it, but as you can see, it has some pictures and stuff like this, but it has this Kepler in it, which I like, because I did a video in the past about Kepler in my SQL Server Geospatial series. I think it was video number 6 or something. I'll put a reference to that in case you want to go in more details about it. So you can install this viewer in your project here. I'm going to go back to my files. I'm going to actually go and see if I can look at these files a little bit. So let's go to Illinois here. This is what the file looks like. So it gives you a preview, but I want to go in and I want to right click on this file and say view map, because once you install that map viewer, the Geo map viewer, you will get this menu option when you right click on a spatial file. So when I view map here, it opens up and then it loads the data, as you can see here. So we'll spend a little time going through some of this stuff. As you can see, you're getting tooltips with it. It has these different sections here. Now, if you want more details, go to that video I'm going to be listing, because I go through all this stuff in more detail there. I will not spend a lot of time on this here. I will just kind of move through this fairly quickly. But you can add data, as you can see, and you're getting this. So you can load CSV, JSON, or GeoJSON, and you can drag and drop them in here. Or in my case, since they're over here, I can just browse to my files, go into that folder there, and then I can add, some additional fields here. So if I want to look at maybe the one I'm looking at now, some things I can do with it. I can hover over like this. When you click on this new data set, you can give it a name. So this is Illinois. So we'll give it a name. So I can add more data sets, more files in here. I can add layers in here. So if I just look at the Illinois, for example, you can see it pre-retrieved some of the fields in here. So it detected it was a polygon, but you have different types depending on what your data looks like. Because these are polygons, it detected it, and it just came back with a polygon. Also, it figured out which field that it's going to use because it was a GeoJSON field. So that's what it's using in this case. Then it has a fill color. You can shut these off. You can turn them on, and you can see what happens when you do. You can just see the stroke color, but if you don't want to see anything, you shut that off too. But that's probably not a good idea. But the stroke color, you can, space it on a field, or you can base it on a color. So yellow outline like this, you can see that. And you can set the fill color. One thing you can do, you can select the field. So if I select I gotta turn it on, and I select a fill color based on a field, I can say, let's base it on county, for example. Notice I'm getting these. And now you're getting fill color themes as well. And I can choose these different ones here. So I can choose different ones like this, depending what kind of colors you like. And one thing you can also do, you can create a custom. Another thing you can do is, you can see here, it uses 6 different types of colors. I can set that to 9 or whatever too. I can change it. I'm going to leave it at 6. So what I did was I based it on county here. That's why I have additional fields in here. And what I can do also is I can say, hey, I want to see some height. So I can drag that up and it gets a little taller, but you don't see it. In order to see it, you got to go over here and choose this 3D map. So now when you move in, you can see it looks a little better, but I can also raise it. So I can, I can push it up like this. I can also do the stroke width, but it doesn't have a good color right now. And I can set the opacity, obviously. There's also some additional things you can do with here with the labels and so forth. I haven't really delved too much within that, but you can see the stroke color can be based on something too. So anyway, there's a lot of stuff in here, and I don't really have much time to cover it all. But you can add filters, you can select the field you want to filter on, and so forth. So the other one here is to create the tooltip. You can clear it all and add more tooltips. You can choose more stuff you can put into the tooltip. And of course you have labels you can use. You can bring the label to the top, as you can see here. Now the label is overlaying here. And you can choose map styles too. So here it's sitting at dark. You could go light. You could go satellite. So now you can see it better. You could also make this more opaque so it shines better through. So there's a lot of options within here. So that's one thing you can do. You can analyze this data inside this map viewer, which is pretty cool actually. I went to a Wikipedia page and it looks something like this right here. And what I did was I found this table in here, Illinois airports. So I took this table here and I basically put a inspect on it. So if you go in and say inspect, and you click on this one here, and you scroll down till you find the table, for example, right around here. I did this T body. I went to this T body right here. And then I right click and I say copy. And then I copied the XPath out of it. And when you copy the XPath, you're getting this part comes back. So you can see this one. So here's the XPath you copied back. This is the website. So I wrote this little code here. You can have a request and you create a URL which is pointed to that Wikipedia website. And that's the area of the page you want to extract. Then you can write a request to get a response. You use this request.getURL. Then you take the HTML and from string it for the response content to load it into this variable. And remember, in the beginning, we loaded some libraries. This was one of them. So this is the library that we're using to do this. And then I use this tree, this part, and the XPath goes in here, which is this expression here. So it's going to read through all that text and extract this portion of it and create a table out of it. Then what you can do, you can convert it to a pandas data frame. So use pandas read HTML, take that HTML to string, and you load in this table you just extracted out. And it's the first list there, as you can see. I'm dropping everything that doesn't have data in the rows. There's a lot of crud in there in that table, and when it comes back, there's like 125 records, I think, but I was only able to clean up about 42 or 43. But it only serves as an example. We don't care about all the data. So that's what I'm doing here. I'm dropping that stuff, and then I'm saving it CSV file, and then I'm printing it out. So let's run that code, and you should get another file over here. And there it is. So you can see it cleaned it up. It has the city served, FAA, so that's the column. These are the airport codes. So ORD, for example, is O'Hare, ORD. So that's the FAA. That has the description for that particular airport. So when you open up this map viewer, you can see there's a little orange thing here. When you initially load it up like this, and you're in this first layer part, when you click on this, you're going to see a lot of data sets you can actually load. And the one that I was looking for was this USA airports. So you can see it's at GitHub. So you can choose this one, and it will look something like this. I went there to this address where that was listed. And then I went into the actual file itself, which sits here. So that's the geodata viewer file. It's under data, CSV, and so forth. So if you look at it, you can see here's CSV, and then you can go to and find that USA airport CSV here. So that's what I'm doing. So this is what it looks like in a raw format. Notice this config, and so forth. And further down, there is something for data and so forth. This is the data I want, this piece. So in order to get that, I go into my file, and I have to drill in. So the easiest way I found to do this was to download this file to my folder and then open it from there. So let's do that. So let's download that file to that folder. Okay, so let's download that guy. Okay, so now I download the file and I put it into this folder, as you can see here. So let's go back to the Visual Studio Code. And as you can see now, there's a USA airports.map.json. Now I could have just gotten the CSV file, it would have been a lot cleaner, but I wanted just to show you how you can work with JSON as well. So here I'm opening that file, the JSON file, as a read. And what I do is I load it into this variable. And of course you're importing JSON to do this. And then from there, you query into this data here by grabbing the data sets. Is a list, and then there's data, and then there's all data. And that's the structure of that file. Then I'm creating some columns. Those are the names of the columns I want to use. And then I want everything to be strings, except for the last two, lat and long, to be float. Then what I do is I create the data frame here, as you can see, and add the columns. And then I drop everything that has none or null value, or NAs or whatever you want to call it. I drop that out there so I get clean data. And then I loop through it here. And then what I do is I just load those columns into the data frame, as you can see, and set the type for each column like this. So let's run this and see what happens. Okay, so it's done. So now I have loaded into memory this data frame that I call DF_US_air, I think I called it. Okay, so we have the DF_US_air already loaded as a data frame now. Now let's create another data frame, and we use this DQL-T, output it as a data frame, and then we give it a output variable called DF_Wiki. And it's going to look something like this. I'm going to rename some of the columns in there. So I'm running the query here, and you got to use the double quotes, otherwise you get some weird results. And I'm going to load it from the CSV file we created from the scratching the HTML. So let's run that and create a second data frame now. And you can see it here. There's an FAA, which is the one I want to join to that other data frame that we created. So what I want to do then is I want to create this merged data frame. And there's going to be DF, what was it called? US_air, was it? Left join it on this IATA from the US_air, and then I'm gonna right join it to the FAA column. So that would be this one right here. So let's try that and see what happens. And once, if that works, I'm gonna drop the city column, and then I'm gonna show the data frame. And here you can see it finished. Now it has a couple of extra columns. We could drop those as well. I could add some more columns to drop this, but I'm just gonna leave it in there for now. So here you can see there's also a number of passengers for each of these. For that year, how many passengers went through that airport or under the flights? How many passengers boarded the flights, I should say. I'm going to create a table, in-memory table now, call it Wiki US Airports, and I'm going to use a select statement where I'm going to get certain columns like this, and I'm going to generate a geospatial column based on the latitude and longitude by using this st_point from this merge data frame. So I'm going to run that, and as you can see, there's 40 records that extracted out. Then I'm going to copy that table I just created now to this GeoJSON file like this, and I'm going to use the format using GeoJSON and using GDAL, the library, to actually create it. So let me run that. And okay, it's done, 40. So now I should have a file called Wiki US Airports GeoJSON. So if I'm interested in looking at that one, this is what it looks like, as you can see. And what I can do is I can view that in a map too. And here you can see, here's all the Illinois airports. That's why I created this one file here earlier that looks like this one. Okay, let's just look at it very quickly. It has two data sets, as you can see here. And you can view the data here by clicking this little thing. This is the one we just created, the FAA and so forth. Yeah. And the other one is just the Illinois Census Bureau data. So as you can see here, it generated all this stuff. Here's the GeoJSON column here, and passengers and so forth. This one is showing the wrong data because it doesn't have the numbers on the passengers. And the reason for that is because when I created the data frame originally, I used single quotes, but you should really use double quotes in the query itself. So let me just show you very quickly here. Use double quotes here, otherwise you won't get, you can see here when I used it, I'm getting the actual numbers. So that's what you want to do. But making a long story short, I'm just going to use this previous one I did here so you can see it. So I got two layers basically. I got new data set and the Illinois counties. You can see it here, and there's two layers, and the other one is a polygon one, and it's set to a fill color. It has a stroke color, and then you just adjust the radius and the stroke width to get these two colors, as you can see. So when you hover over it now, you have two layers. You have the Illinois in the background. So there's tooltip for that one, as you can see. And it's based on people in poverty. That's the underlying. And then when I hover over this, as you can see, I'm getting the tooltip for the second layer, which is the airports. Here's O'Hare, you can see. Okay, I want to do a final example just to show you there are a bunch of functions within the DuckDB ecosystem you can use. If you look at it here, there is all these different kind of functions you can take advantage of, and it tells you what is required for it to work. We already did the st_point one with the two doubles in it to create, I think it was the airport shapes. I'm going to use this st_read function because it says down here that it's very flexible and you can actually use it to read GeoJSON. You can see it down here. What I'm going to try to do is use this read function, and notice there's a bunch of settings you can use for it. So you need to kind of read through this to see what you need in your case. So what I want to do though, I want to read one of my existing GeoJSON files, and then I'm going to use that st_read function, and then I'm also going to use another function. So let's go and look at that one. I'm going to take the California counties. So if you remember, that's this GeoJSON file up here, the sent from the Census Bureau. I'm going to use the st_read function first. So I'm setting up a create or replace table state for the CA counties. And then I'm going to say select everything from that GeoJSON file that we have saved up here, this one. So let's try to run that and see if it actually creates a table out of it. All right, so I'm going to run that. And as you can see, there was 58 records that came out of that one. Now what I want to do is I want to use this st_union_ag function. And what that does is it takes some of those county shapes and it merges them into one bigger shape. So it basically aggregates and combines those counties that I select into one bigger shape. Create another table because I need to keep it separate from the other one. So I'm gonna create this new table here, and it's gonna be based on this select statement. I'm gonna use the stUnionAgg function, and I'm gonna select the geom column that is the existing one that we are using for California, GeoJSON file. So I'm gonna combine those into this field from this table we just created up here, as you can see. So I want to filter out based on certain counties. So I grab the ID from some of the counties that are neighbors to the others so I can get a bigger file, and they're together. So that's what I did here in Northern California. And then I have to group by ID. So let me run that. And I got an error. So let me go and check what that is all about. Okay, so of course I made a mistake because I tried to create another table. There's already one in memory here. So in order to get around that, use this, create or replace table. So I can run it over and over here. So as you can see, I used 7 of those shapes, and they are listed here, and combined those. So that's where you see the count here. Okay, so now let's save that one, the new file we have, and we're going to save it to the file system. So I'm going to save it over here. Let's go and do that. So that would be this one here. And I'm going to copy it over, and it's done. And as you can see, here's the new file up here. So this is what it looks like behind the scenes. So let's take a look at it now and see what it actually looks like. So I have this California county, which is this existing one here. Let's go and actually see what it looks like. So I'm going to add another layer, another data set, which is that new file, which we called counties ag. So let's open that guy. And as you can see now in green, that is that aggregate. And if you want to see it more closely, we can hide the under one. So now you can see this is the ag function. Now notice the tooltip only says the name of it because I didn't add any more columns. I just did the shapes. If I wanted to see like ID and all that other stuff, I would have to include that in the actual query that generated this. So again, you can see, you can show it, you can hide it, we can move these layers. So here you can see that one, and you see the underlying one, but it's overlaid by the bigger one. So of course we can hide that too, and we can hide the other one. So now you see it again. So I just want to show you a couple of extra things about the geospatial, not just making files, but you can actually use these functions too. You just need to read up on how to use them. So anyways, I don't want to spend too much more time on this. It's been long enough. I hope you like this video. If you do, give me a like and consider subscribing to my channel if you haven't done so already. All right, we'll see you really soon. Take care, everybody. Bye-bye.